All right, good afternoon and good morning to our audience. I'm excited to introduce a leader in the world of data architecture and engineering within the power and mining industry. Jorge Luis Bravo. He's founder, chief architect, data architect at JJ Tech Innovations LLC. From nearly 30 years of experience optimizing data systems, Jorge Luis Bravo has built a reputation for transforming operational challenges into scalable AI-driven solutions, positioning JJ Tech Innovations as a trusted partner in the mining and industrial organizations. Jorge's work redefines how organizations organize and leverage data to achieve higher efficiency and profitability. We're thrilled to have you here with us, Jorge Luis Bravo. Welcome to the show.
Hey, thank you so much for having me. I feel like, from myself, my perspective about what I am doing is I love what I do. And I really feel like, sometimes people do what they love and they just keep doing it, and you progress and you keep studying and innovating. So I think that's a great opportunity that I was able to take it. And yes, I'm happy to talk about a lot of experiences that I have. So yes, thank you for having me.
That's awesome. Yeah, we're gonna just have a nice conversation. I want to know your background, which how your journey started, how it led to the creation of JJ Tech Innovations, where different industries, major industries you're seeing, and that you've worked around with, and then we'll dive into challenges that your maybe current project stakeholders are facing, and then we can wrap up with any advice for future innovators and listeners on how they can connect with you and any advice that you have for them. We'll do 30 and 40 minutes. Is that all right for you?
Yeah, absolutely. That's perfect.
Awesome. Well, thank you again. As we mentioned, you spent nearly 3 decades working across mining, industrial systems. Please walk us through how this journey began. What drew you to focus on this industry specifically?
Well, yeah, so the interest about digitalizing data started very early at the beginning. I mean, so I got the opportunity to, at the beginning, start looking at computers when we were just having the original old timer PCs. Like, I remember I have a one PC that it was only 64K. That's incredible, and I only have a floppy disk, and there is not much I could do with a computer. So I started learning assembler and quick basic and basic. So I decided to start building games. So
Like
when
video
I
games.
like video games exactly, but very, it was like arcade games.
And that type of technology was it futuristic back then, or did you guys
Well,
think it was like still?
I mean, when I was building those games, I mean, the actual monitor, it was like the TV monitor. So we only have certain amount of pixels. I think it was like a 200 pixels by 500 pixels. So it was it was the old. But the good thing is that when I start looking at arcade games, I start understanding how to draw things on the screen, how to make the little ship to move from right to left, and when I was uh, firing, the bullet was going in one direction or it was going on a certain degree direction. So I have to use formulas and, I mean, trigonometry to make it look like. So it was the illusion that the little ship, which it was a shape, it was firing and it was reaching a particular other ships that were on the cloud. So when I was doing that programming, I understood the connection between that visual and behind the scenes zeros and ones. So that's when I understood, oh, so the computer, he's the computer actually is dumb. So that's what I understood. The computer is going to do exactly as I say. And when I was, for example, I always remember that I got a friend that he came from school, and he was like, "Oh man, this is so difficult. Can you do something so I can fire a little different, maybe a more powerful weapon?" So for my friend, he wanted me to build a more powerful weapon, but in my head,
in the video game.
yes, in the video game, but in my head, there's no powerful weapon. It was just more like making a few lines of code instead of 1 pixel, make it 2 or 3 pixels.
Mhm.
So it gives you the illusion that it's a more powerful weapon.
Make the radius of the projectile a little larger, and like the gun maybe
Exactly.
look a little different. So it maybe like it looks like it's like a bigger gun, but
But it was
it's
just a
just a.
formula.
You said that these guys from school. Is this the university
No, 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 no,
or
no. That was high school.
high school? You were making
Yes,
video games.
yes, high school. We were not sophomore. We were like a junior,
Us.
and yes, and then I started doing the gaming. But what I also remember is that I loved to be on that computer. It was fascinating to be able to have some sort of like a keyboard, type in some coding, and run the program, and the program was doing something. That was amazing. That kind of feeling that you can create something.
It's a great feeling because I'm sure you know. I'm sure you have so many instances and experiences where it doesn't work, and then
Yeah,
when it finally works, you're like, "Oh my god, it works!"
yeah, exactly. So most of the time, you're right. I mean, I was just doing something and it was messing up, or I was, yeah, the whole thing was falling apart. And there was like a coding, coding, coding. And remember, at that time, there was no Google, there was nothing. So it
No
was
AI.
no AI, no nothing. So I have to figure things out by myself. So I was just coding all night long. And I still remember, I mean, I came back from high school, I was coding, sometimes when I was almost ready, almost finishing, I still remember looking at the window and the sun start rising. It was like a 5:30 a.m. in the morning. So I'm like, oh shoot, I need to go take a shower and go back to school. So, well, I was fascinating, and I was kind of like my brain was kind of like a shape for that kind of thing. So that's how everything started. I mean, my vision of zeros and one, and what can you do?
Do you think that going from making video games for fun as high school and then working with real professionals like in project management, in power projects, mining projects, do you think that it's necessary, like that experience that you had coding, is that important to have? Or what do you think about how we have Cursor or AI now that codes for you? Is it like where's the difference in the experience?
That's a very good question because a lot of people, for example, that I do know, especially some colleagues, for example, they decide to choose computer science because they said, well, that's going to get me money.
Yeah, that's what most people think. They say computer science for money.
Yeah, exactly.
It's the
Most
only
people
reason.
do that, and I always remember I got a friend, I got a colleague that I don't remember he was coming to work and he was doing his job, no problem. And one day he was like, I really hate this job. And I could not understand. I could not, what do you mean you hate it? I
At
mean,
work, he said this.
yes, at work. I mean,
My
I'm like,
God.
how come, what, you don't like this job? "No, I hate it. I hate it all my life." And I say, so why you come to work? He said, well, I need the money. So yes, there's some people who actually choose the career. They probably do it, but there's no passion. And he was just doing exactly what you're telling him to do. And there are some people who do that. So you asked me the question, is it important? I would say that it is important for you to do what you love, for you to do what is actually what do you love. Obviously, most people will say that's a luxury that I cannot take. I have a family, I have people, I have my kids, I need to feed them. So yes, I want to sell ice cream, but I need to pay rent. I understand that. uh,
Well, we know some really successful ice cream business owners who
of
are
course.
doing who that exactly was their passion.
Yeah, but
But
I'm telling you a little bit more about reality. So if somebody is young, I mean, and if they want to immerse in any kind of thing or passion, you need to choose your passion, exactly what you love to do. It could be anything. Like for example, I mean, if you remember um, Steve Jobs, he only took one semester in college, and the last class that he took, it was calligraphy, and he was fascinated about the calligraphy, and he was fascinated because he was perfectly aligned. And then he said, because at that time the computers, they were like a more like a squarely shape, no, but he was like, no, why don't we create something that is actually well written with calligraphy? So that's how he was vision. His vision was to do something perfect, so not so robotic kind of thing. Okay, so you need to choose what you love. That will be the best advice.
and just piggybacking off of that Steve Jobs example, when he was speaking in about his every time he spoke about his father, he would speak about, like, let's say we have a cabinet, like there's a cabinet right here in our room. When and his father was like a woodworker, he would build fences and all that, and he would teach Steve Jobs that even behind the counter where you can't see it needs to be built correctly, and be
Exactly.
designed well. And it's really bizarre because the way you said it is you can see it in his work in the iPhone, like inside the chips, like even though no one can seize it, it's designed like beautifully,
Exactly.
even inside in this MacBook that we have right here, the interior, even though no one can seize it, he pays attention to that detail. It's ridiculous.
That is exactly right. I mean, and the only way to achieve that is to have that desire to do things right. Because, I mean, for example, you want to prepare a food, okay, for your family. I mean, anybody can take a egg and just put some rice, put some water, and that's it. But if you really want to go, I mean, you don't need a lot of money. You probably need maybe just a few more ingredients, and you can create something nice, something that is actually you put your effort, you put your passion, you put your desire to do it right. It's like you have your house, for example. Nothing stops you to clean it up, to take all the dust, to pick up the papers from the floor, to make it look nice. You don't need to be a millionaire. You can actually have your house looking beautifully, but it's just your passion to put it to make it right. And that's how you build systems. That's how you build technology. So, because technology is more than just uh, building something, it's more like it's your opportunity to create something and make put your signature over there. Anyway, it's more like a perfectionism, but that's
And that's not perfect. That's the way, and that's why they pay really good money for people in this industry, because any normal person who doesn't care, let's say they're building an AI workflow, for your data integration from different sources. And you say, this works, it went here. I copy and pasted this ChatGPT code into this webhook or whatever, and it works, but then there's like some sort of latency or something, and they're like, it works. Move on to the next thing.
yeah,
And
that's a problem.
a real, like a true professional and who has the passion will actually dissect it more and take the time. And we're tired sometimes, after working hours and hours of just being in front of a screen. We say, you know what, man, like it's good enough, but
Eh,
that's not the way you
I
do it.
think that's a big problem because, I mean, if anybody does anything about computers, I mean, everybody knows that when you build some sort of solution or automation, anything can happen.
Mhm.
So, if unfortunately, yes, you are right. You made a good point about, let's say you tell ChatGPT, build me a code to do blah blah blah. Yes, you can take. You're right. You can take the code, put it in. But in the reality, I mean, there is a lot of factors. What if something goes wrong? What if there is a data is wrong? What if instead of loading, for example, 1,000 records or 100 records, because most of the time the sample code that you receive is just for a proof of concept that normally it reads 100, maybe 200, maybe 1,000, maybe 2,000 rows, or maybe 20,000. But if you really want to build something that is stable, where you're going to put it on a real scenario, we're talking about millions of records. So then you need to consider memory, you need to consider latency, you need to consider a lot of things. And the only way you can understand is if you have the experience. The experience doing stuff, that's what it makes the difference. Because you build something and you say, hey, I need to do this quality, I need to do this transformation, I need to make sure the memory is there. I need to make sure that the same data that I read is the same data that I have finished loading into my system. So you need to put all the checksums, all the check-ins, and then once it's there, build other things, transformations, qualities, and everything else. The only way you can achieve all those flows is with experience. And that's something that you cannot get away with that. I mean, you have to build something to work that actually works to be able to, you know, grasp all the experience.
Yeah, because as you probably have seen in the past, and like you say, it's very important to make sure that the data that comes in is the one that comes out. And with AI now, what if someone types in a long line of code, which you've seen it? I mean, the AI can hallucinate. It will create, like, let's say, and we've seen it. You know that we've made uh, back ends for different solutions with this. We say we want this to happen. Like, let's say, for example, we want it to send like input X. Then it will like name it for you. Like it will hallucinate and say, like, user input X, but the webhook or the trigger that you have is named something else. And if someone just copies and pastes that, and then it's a long line of code and keeps doing that, then the names are not the same.
That is, yeah. So what's happening is that uh, when normally, I mean, if we are using, for example, add-ons, which is AI normally is, it helps you. I mean, we need to be very careful understanding how AI works, okay? If you build something by hand, which is the traditional way of doing, which right now, if you take a look at that, almost all processes are being done by hand. So somebody, if you're in a bank, for example, and then you take money out of the ATM, for example, there's a piece of code that takes it, count the money, goes, check the balance, check the information, produce a register to do that. It goes to quality checks and everything, and the whole thing is done. But there is a lot of piece of code about that, and many systems. That is, and it's very complex. But in order, if you want AI to do that, then you have to tell AI exactly what you want AI to do. But since AI, it's
Truth finding.
it's exactly it's kind of like a fact true. It's like a fact finding, like a true finding. You're right. I mean, I get the feeling that it's not yet ready to say, build me a code
Mm.
to get money out of the bank and I am not going to read it. I don't think so. Yes, I think for right now, hopefully AI will be more smart. Now you can use AI and you can make sure you put the right prompts, but still you have to know what's going on. So AI is an add-on, but the business rule still, at least for now, is being it has to be managed by a breathing person, a human being.
So, in your experience, you've had experience, and we'll dive in. Mining, we have power, construction. Let's say within those three industries, how did your experience with those shape the way that you see how about technology improving the processes like AI? What can AI do for us? You know, if we can't make code, how can AI help in those industries right now?
You know, that is a lot of people talk about AI introducing in different technologies and in different industries. In my experience, the best approach to introduce AI technology is having full, well documented processes. Like, for example, if we are reading sensor data, for example, for a power plant or maybe a operational plant or something, I mean, some engineer, it needs to understand all that information, not just the data, it's the
Hmm.
information. And the engineer, it will understand, it's going to say, you know something, it's information from these sensors is aberrant, okay? Or maybe is standardized within a certain window, a certain thresholds, for example. I think everything is okay. But if, for example, sensor data or temperature goes maybe strange behavior, no? Spikes, okay, then the engineer, they have to understand and teach the AI, saying, by the way, you know something, you're going to see this data, but if you see these spikes, something is going to happen. Analyze it, what's going to happen, okay? So you have to teach the AI. And once you teach the AI, AI can do their work. Or for example, something interesting. If you have sensor data, for example, and then temperature start jumping a little bit, okay? Maybe for this equipment, there is no problem. But the next one, it might be affected. Or maybe the flow, for example, there is a variation in flow in one equipment, one valve. Maybe in the next one, there's going to be more pressure. So this other one might be affected. And then not in the readings of the sensor will be okay, but the next one, or maybe some other equipment might be affected. So that kind of in the understanding, if we tell AI, look at those all of this data and be careful about the ramifications, then we can see a real value. We can understand, for example, maybe we need to do maintenance on a particular equipment, or maybe we are forcing this other equipment, or maybe we are making more pressure on a particular pipe or valves or something. Then you can actually save millions of dollars on predictive maintenance rather than just focusing on a piece of equipment that it breaks, and then you need to shut down the whole plant and then fix it, and then you probably have 12 hours of no production, and those are every hour is millions of dollars. That is an area.
And not even getting into the mortality rate of safety, not even
Oh,
touching on that. You're talking millions of dollars saved. I mean, we're talking about equipment failures, uh, but we're not even getting into actual safety and all that. So let me ask you this: you're saying these sensors are using predictive analytics to alert the team so we can go and do maintenance on certain equipment. At what point are we automating a certain change? You know, is there us is are we not there yet with AI where, let's say, temperature is spiking in a certain pipe, or something is going a bit off, like a bit higher level? Is there a point where AI can decide to shut it off? Or
no. At this point, only is an alert. Like, and the reason for that is because you need to understand. For example, in a power plant or on a bigger operation, we are not talking about 10, 20, I mean, equipments. No?
Mhm.
We're talking about hundreds of thousands equipments. So if you see, for example, a refinery, okay, a big or a power plant or a nuclear plant or maybe a mining operation, I mean, if you take a look at the whole thing, if you take a look at all the spikes and all the sensor data, it's going to be all crazy that if you have a person who can see that, it's just noise.
that is the word, yes, noise.
It's just noise. And if you say there is a spike on this equipment, shut down the plant, you will have to shut down the plant every hour because it spikes all over the place. So the art is the AI could be taught to understand all this noise and say, you know something, these are warnings. That's okay. Because it's okay. I mean, right now, for example, there is a pipe, maybe it broke, but nobody cares because there's no effect. But if there is a pipe that breaks in a cooling tower, for example, or a pipe breaks in a concentrator, okay, then you have to shut it down
Mhm.
because if not, then you really got a problem, big problem. So there needs to be some kind of severity on the different alert systems that you have, or maybe the noise, it doesn't look, it looks like it's just warnings, but the AI could be taught to say, you know something, these are warnings, but if the warning continues for another week or two, then we need to be worried because we are stressing a piece of equipment. Then that would be an alert. So, but if you have a person looking at all the different screens and dashboard with all these different indicators, he's going to look at all that and he just doesn't know what to do.
Mm. Do they really not know what to do? Like, I would assume these guys were heavily trained.
No, 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 no. Don't get me wrong. Again, if you have 100,000 pieces of equipment,
Hmm.
obviously there are some of them that are key, and those ones that are key, they know them by heart. If something is wrong with some of those, they know what to do. But what I'm saying is that instead of looking at the bigger pain points, AI can actually see the whole thing.
Hmm.
And because normally speaking, an operational plant, most of the time you have maintenance and you have to shut down the plant maybe every 6 months or 9 months, and then it's in maintenance for so and so. But if you have some AI can help to understand, you can actually, instead of shutting down the plant, you can just easily fix it, fix. It's kind of like a self-fixing. It's like a human body.
Hmm.
It self-fix it all the time, or you can actually fix it when it's not necessary to shut down the plant. That's what I'm saying.
That's amazing. Well, why don't we go back down? We're kind of in the future right now. Let's talk. Let's talk some more about roots. You were talking about these mining operations and how AI could take all the noise and kind of like evaluate it and really kind of sort it out for us, saving hundreds of hours and potentially millions of dollars in defects and catastrophic events possibly. So tell me, in what's the first that comes to mind in one of your mining operations where you saw a power plant close? You know, what was a situation when you said that these plants close every 6 months and like they have maintenance? Well, what's like the
Well,
first most like?
normally, when I was saying that, I was referring into power plants.
Oh, let's talk about that then. What is the normal situation that would occur that would result in having to shut down a mine for some time, or excuse me, a power plant for some time?
Well, it's like when you have a car, for example. Okay, it's as simple as that. I mean, you need to do oil change, for example. Okay,
Tire pressure low, you know.
exactly, something like that. It's, I mean, a normal operation that has so many, I mean, different equipments and so many different areas, and it's too much. I mean, uh, they have a scheduled maintenance that actually works over the years. They know exactly how everything works. Okay, everybody just stop a particular system and they do maintenance and continue, and that's a normal thing. It's been working
Very
all along.
efficient, surely.
Yeah, it's been working all along, but stuff happens. Okay, maybe somebody forgot to take something, or maybe something happened and you didn't realize, and maybe a piece of equipment is been sending alerts, no, sending alerts, and then one day it just breaks. That's a normal thing. So all I'm saying is that having that kind of preventing understanding, that will help to prevent and to make it more seamless operation. And how you do that right now, unless you got a guy watching every piece of equipment with your own eye, that would be an impossible task. But
Even with like 10 guys, they
yeah,
they, they get tired. Human error comes into play.
exactly. But if you make it digitally, if somebody can actually look at that digitally and understand, that is the future.
What is it? What is probably like a roadblock or a doubt that's preventing these companies? I mean, I keep going back to mining because that's kind of our topic, but in general, the industrial sector, from adopting AI faster, is it cultural resistance or lack of readiness, or is it trust?
Well, obviously, I mean, it's trust, because that's the number one, trust. I mean, it's like, for example, why we, even though we do have autopilots, okay, for airplanes, okay, the question is, why don't we put autopilots for every single plane? And the answer is because we have 200 or 500 people inside.
Hmm.
So are you going to risk the lives of 500 people? You're going to say no. You need a human being. But the pilot can be there, and the autopilot can help a lot. So number one is trust. But the number two problem is the challenge right now that most companies have is how to manage data.
Hmm.
Okay? Why is that? Because, as I said, if you have you have a large number of sensors, a large number of information, and it's not like a sensor number one is going to give you data, and sensor number two is going to give you data that you can easily understand. No, these sensors come from different manufacturers, different countries, different languages, different unit of measures. So then you have all this sort of data that it look like a, how can,
Gibberish.
yeah, it's gibberish. And so you need to look at each one of those and try to make sense of all of that and put it on a common data environment. And but it's not just that, because you need to make sure that you read data in a consistently basis with all of these ones. And if if you read all this information, it has to be uniform. Because if what's happening if you have all this information and then a very important piece of data, the, something simple as somebody drip and breaks a cable or something like that,
Mm-hmm.
then the computer is going to say,
Plug it back in. Plug the cable.
no, not,
Or
no, no, no. The computer will say the equipment is shut down,
right.
but the computer is not shut down. Somebody just trip and cut the cable.
Right.
So so computers are dumb.
As we were talking about from the beginning.
Exactly, computers are dumb. So then you need to make sure that all this is homogeneously correctly, or you can trust on the data. I mean, you can trust it, and then start to making decisions. But you cannot fully automate, because once you have all this information, you need some warnings and some information, some dashboard, and say, hey, you know something, I feel like there's something going on, is wrong on the room number 2, where you have all these different information, different equipment. Somebody can take a look at that and say, okay, instead of looking at hundred thousands of equipment, you go there and say, oh yes, somebody, I forgot to connect the cable, or something wrong, or indeed the equipment is rusty, or they had a problem. So then you need to do something. So the number one issue, obviously, is the trust, but it gets into how can we utilize information into an area where we can trust, building some sort of like a common data environment, like a central repository of data that we trust. I think that's the number one.
For some of these companies that don't, like, because as we were saying, especially when it comes to certain industries, maybe they're still doing stuff manually. But we're talking about creating a centralized, unified source of truth, like data environment. What does that look like? When I imagine, I say the most simplest way is like a dashboard on your computer. But how would you describe it to someone who doesn't know? You're talking about data integration, and they're like, okay, but what is the product? Like what do I get? Like, what is the thing?
Yeah, it's kind of like, for example, I mean, um, it's more like a centralized place where you fit it. You just It's kind of like you just throw data. You just throw data on a consistently basis in a real time, and it's that kind of technology, having a common data environment with right now technology is possible, because they know that, I mean, maybe 20 years back, the price of storing data, it was very, very high. I mean,
Before the cloud.
exactly. But now with new computers, I mean, pretty much storing large amount of data is not a big problem, I would say. So
Pay as you
then,
go.
yes, and so then if you throw millions of records every hour, it's okay. So companies normally they have this perception that, I mean, I need to put this data, but how do I organize this information? Because remember, when the cloud and data warehousing start coming into play a few years back, and then they it kind of like evolved with what they call data lakes. Data lake was a concept where you can just throw everything that you have, everything, okay? But without any control, a lot of data managers, they understood that if you put data into these data lakes without any control, without metadata, without understanding of the data, it becomes a swamp. Okay, so it's kind of like you're throwing data, but then it's unusable because
Disorganized.
it's disorganized. So you want to make decisions. Oh, is data? Where is this from? Oh, who put this data? Or oh, is this meter? Is this miles or is this meter? I mean, what kind of unit of measures? I mean, so when the data is disorganized, then it's the same concept as garbage in, garbage out.
In 1 year, out the other.
Exactly. So, one of the main issues the companies have is that they don't spend the time to analyze and organize their data, and they try to put everything. I would say that's not very practical. If a company, a mine operation, power operations, or any kind of like a big operation, they want to start adding into the digital execution, they need to start with understanding the processes. And if you're putting a particular information into these common data environments, every single field, every single piece of information, it has to be understood because we are talking about zeros and one. They have to be they have to be understood as information. Then, when you put information that you know exactly what it is, you put in these data environments, common data environments, then you had a process where you add source number one, source number two, source number three, four, five, six, seven is all well organized, and then it really becomes a digital transformation process. That's how it is.
Maybe for the audience that is wanting to understand a little bit more about this, from project management perspectives, they teach us the difference between raw data, raw information, and then reporting, right? What would you say is the difference between, because I'm sure there's a fine line, what is the difference between data and information, which you've said a few times already, is different, is something different.
Yes, data is pretty much what you see from from a system. Okay,
Zeros and ones.
exactly. For example, you have information, a roster, or you have, for example, data from inventory. Okay, from your warehouse, or you have information, for example, sensor data, or even your inventory of equipment. Okay, this is data. This is just data.
Mm-hmm.
And maybe the data looks perfect. Okay, everything is aligned, everything looks perfect, but what if it's wrong? Okay, because there is one thing about your data. For example, you have an Excel spreadsheet, you have all the information there, all the fields are filled up, all the information. If a human being sees, there's nothing wrong. But when you look further and say, hey, wait a second, I mean, this equipment is not in this location. Who put that data? But it look okay. But maybe it's wrong. So there is a difference between data and information. Data is the representation of something, but the information is what makes you jump into decisions.
Filtered, organized, and quality checked.
Exactly. That's the reason why when you put data into any kind of place, there has to be a data quality validation. And the data quality validation is going to say, hey guys, I have this equipment with this tag. Okay, but you said that this equipment is probably, for example, a valve, okay, or a cabinet.
Mm. A door.
But
Yeah.
then when you see the tag, you say, well, but the tag doesn't conform with that cabinet. What happened? And somebody will say, oh, forgot, I made a typo. I made a mistake.
Mm-hmm.
So there's the difference about data and information. So the data quality is extremely important if you want to elaborate full automation into any kind of process.
What's some advice you'd give? Because I'm sure you've seen the news. Power companies and mining, especially with rare earths and minerals, is not reducing. It's not going. In fact, it's going to be going up, especially in the United States. And we know a few engineering firms that are even planning to open even mines in Colombia. Panama is big, and even especially Australia now. What is the advice that you'd give in a data perspective? What is something you would suggest, or what is some advice you would give to these businesses looking to invest in international projects from a data perspective?
Well, from a data perspective, it is well demonstrated that anything that is it has automation, it definitely produces better quality. And sometimes automation is expensive, and most people, they don't know how to start because they see that this is a very kind of like a tedious process. So my suggestion is start small,
Mm.
maybe with a process that it could resolve main pain points. I don't know, maybe safety, maybe quality, maybe maintenance, maybe purchasing,
To get your foot in the
storage.
door.
Huh?
To get your foot in the door.
Exactly, something that they can actually see, because this is a very sensitive decision. How can you prove management that automation can actually become a value? Is by showing the value.
Mhm.
So then, if you say, for example, we are just starting a new mining operation, so what can we do? Exploration. If we can do some sort of automation or exploration, understanding drone imaging, for example, review the information about all the different samples and all that stuff. I mean,
Mm.
because remember, when you do geology and sampling, there are hundreds of these samples and scientific results and everything. If you put that into the automation and you can see that information, then you can see the value.
Mhm.
Then you can say, oh, okay, so that makes sense. So you can start building all your reports and all your dashboards, and you can see that there is a big connection between your information and actually something that you can touch.
Foresight.
Yeah,
Real.
and then once you see that, say, oh, why don't we expand for something else? Okay, so my suggestion is, if you really want to have a whole, for example, operation being done, that would be very overwhelming and very expensive.
Mhm.
But you start small, then you can do it, unless you have a large amount of money that you can actually invest, which is a possibility too.
All the money in the world can get you what most likely everything you want, but it has to be intelligently spent.
Correct.
You can have all these millions and millions of dollars to make a mining expedition, but are you truly using that drone data to really analyze the terrain or the area, and to make a true decision if that's where you want to mine? If not, you should probably look somewhere else. So that's very true. So anyways, just to maybe finish up here, what is some advice you'd give? Let's say now we're talking to the demographic of professionals in the industry, but what about innovator, maybe college students who are studying computer science or engineering, or are interested in this niche that we're in? What is some advice that you would give them on what decisions to take or experience? What is something that you would give advice you give young engineers or data professionals entering the sector right now?
Well, my advice is that obviously, I mean, a lot of the companies, I mean, they have they operate currently And let's say, for example, we are turning on lights, for example, every day. Okay, so we do have a power plant that is actually working. Okay,
Mhm.
so somebody might say, well, so everything is okay. Why do we need change? But people don't know what's happening actually in those places. So what if I tell you that right now you are paying, for example, I'm gonna make any kind of $100 to do this, okay?
Like the lights.
The light, for example,
Yes.
$100 a month, which is not true, but just imagine. And then the power company, maybe they take $100, but and they actually spend 50 to put the whole operation, so they make some money. So everything is okay. But what if I tell you that if you put intelligent automation operation, maybe you can actually gain, you can save not 50%, maybe you can save 60%,
Hmm.
even 1%. We're
Yes.
talking about hundreds of millions of dollars. So then the answer is, what do we tell to young engineers? Don't be afraid to innovate. Don't be afraid of suggesting better ways of doing things. Because somebody might say, we've been doing this for the last 20 years and everything is okay. Sure, that is correct. They've been doing that for the last 100 years, maybe. But nobody knows that maybe with automation, maybe instead of, maybe with the money that we save, we can do something else.
Hmm.
Okay? So don't be afraid to innovate. Don't be afraid to present new ideas. And just if you have something in mind, normally companies, they are, they in their vision, normally the company, at least big companies, they have room for innovation. So just innovate, do it the best way you can. And the last advice that I have is work on communication, because the best ideas, maybe they just lay in the head of somebody,
Hmm.
but if they have the diligence to
Courage.
translate, or the courage, you're right, yes, to put those ideas into writing,
Hmm.
into something that you can actually present to somebody, that is what people should do.
That's truly insightful. That's very true, and that goes into leadership also, which I'm sure we're gonna have to talk a lot about. Right now, this section has been about data architecture and AI and roots in innovation. So I have to thank you so much for being here with us. Please, if someone were to want to connect with you, conversate with you, or find you somewhere, where would someone look?
Well, okay, so we have our website, jjtechinnovations.com. Yes, we can connect through there, or just look it up through LinkedIn.
Absolutely, LinkedIn is definitely the place to go. We're gonna leave the LinkedIn, both our LinkedIn's and our website on the comments, in the details in the comments. And I thank you so much for being here with us again, Jorge Luis. And please, we'll have you on the. We're excited to have you for the next time. Thank you so much.
Thank you. Bye.